Okay, so we've been working on drawing the Lewis structures for group 1, group 2. We looked at what happens if it's a group 1 or a group 2. We looked at group 3, group 4, group 5, and group 6. And you may ask yourself, like, why do we have to do this? And do I seriously need to go through each molecule and draw the Lewis structure of every molecule that I'm going to see? And the answer is no, you don't. Why are we doing this? The only reason, so why draw a Lewis structure? Why do all this? And the answer is to determine symmetry. That's the only reason why we need to do this, to determine symmetry. And we really are concerned about symmetry when we're looking at polar covalent or covalent compounds. Covalent compounds. So we have a compound, it has polar covalent bonds, and we want to know how will it behave. Is it going to behave like a polar covalent compound? Or will it behave like a non-polar covalent? So that's where we get from bond type to substance type. Like when we said I got my nails done, and yet we obviously were not using just Hankel-Briffs. In order to do that, we have substances made up of polar covalent bonds, yet behave like non-polar covalent molecules. And we use these in industry, and we use them in chemical processes. And so it's important for us to understand how they're going to behave. So symmetry is definitely, it takes some practice, but we're going to get it figured out. So if there is symmetry, if symmetry exists, it is a non-polar covalent substance. If no symmetry, then it's a polar covalent substance, specifically because it has regions of partial positive and partial negative charges, like water. Oxygen, hydrogen, two lone pair, making this a partial negative and partial positive regions. Okay, so let's go back and let's look at some examples. So our first example here is, I'll just grab a sheet of paper here. SiBr2Cl2. SiBr2Cl2. And my question is going to be, what does the Lewis structure look like? Bond type. Symmetry. Shape. Substance type. Okay, so the first thing we need to do is identify central atom. So the central atom is going to be the atom closest to carbon, and that's not a halogen. Bromine and chlorine are both halogens. They only want to make one bond. They are terminal atoms, and silicon is also just one step away from carbon, and so I know silicon is my central atom. So I draw silicon as my central atom. I have 4 other atoms to give homes to. We'll just distribute them equally around the central atom. So I'll put bromine, chlorine. Okay, let's figure out how many electrons we have to give homes to. Silicon has 4 electrons. Bromine has 7. Chlorine has 7. I have 2 each of these. 14, 32 total electrons to give homes to. I begin by assigning electrons to bonds first. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. 32, everybody has assigned electrons. Let's check that there's full shells. 2, 4, 6, 8. Silicon's happy. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everybody's happy. Full shells. So, good deal. And now let's look at bond types. So this is my Lewis structure. Done. All right, bond type. Well, I've got 2 bonds, SiBr, and my other bond is SiCl. So I have non-metal, non-metal, polar covalent, non-metal, non-metal, polar covalent. So both of these are polar covalent bonds. Let's look at its shape. I have, we'll pretend like this is my silicon atom in the center, and we'll make these bromines, and then we'll make orange ones for chlorine. Okay, so here's my shape. And so my shape is tetrahedral. Tetrahedral. So then let's look at symmetry. Is it bonded to the same type of atom in all 4 corners? The answer is no, it is not. And so there is no symmetry, and so it is asymmetrical. And because it is asymmetrical, substance type is going to be polar covalent substance. Boom. A polar covalent substance. Does it matter where I put the bromine? Like I put bromine right here. Would it have mattered if I put them somewhere else around the atom? And the answer is no. Like let's say that this is how I wrote it right now. So bromines were on, like on these 2 sides. It doesn't matter where I put them. It was not going to become symmetrical. And for the sake of my model, you notice I have a short stick and a long stick, and that doesn't matter either. We're just thinking about overall shape of what we are doing. Okay, so let's do another example.